Hello guys, so it's Thursday again, so we're back on the Manta project. Julius has been working very hard last week, finishing up the brake caliper setup, and did some stress tests, which I will show you. And we took the rear axle out of it just to check its its health, basically, which not so good, but we'll get into that in a minute. And for ourselves, what we're gonna do today is we'll actually design the intake manifold in Fusion to have something fabricated for the car. Let me show you what Julius has been up to. Like last time, he did the 3D scans, so those are in there. I'll turn off the handbrake. Well, actually, I'll leave that on. He designed this new caliper bracket, and it's it's going to be 10 millimeter aluminum plates, which will have a adapter bracket for the actual caliper, and it will replace the mounting bracket for the handbrake. This was the easiest option, and quite frankly, it's almost weird, but it fits really well. And we only had to space it out 3 millimeters by milling out a little edge out of the caliper bracket. So yeah, it was quite easy to make this setup fitting with the Brembo brakes and everything, with the brake rotors. So that's pretty cool. He also designed a spacer, so the wheels will not interfere with the caliper bracket itself, like the rims, so that's going to be pretty cool. It's 15 millimeters, so the wheels are actually going to go outwards a little bit more, which will make it look a little bit better as well, and also make it possible to put some wider wheels in there, as we have a little bit more room to the inside of the car, which will be cool. So yeah, that's what he's been up to, and these have been ordered. And they will come in next Thursday. So next Thursday we'll continue on that. And here we have the study from Julius. So he calculated the maximum amount of force when we brake the car from 100 to 0. So this will be complete force at 100 kilometers an hour with a delay and time and force for distance and everything. So he knew what the force was that would be put on the bolts. And actually it's not quite that bad. This looks very drastic, but the displacement is 0.015 millimeters max. We have a safety factor. It says 2.31 somewhere, but that's on the inside where we put the constraint on the steel plate. So that's the steel plate that is connected to the axle, so that will probably be a weaker point than the spacer itself, and the rest of the stuff is like safety factor is quite high, so we could probably make it even thinner and everything, but this is easy for 10 millimeters aluminium, 6061, to get laser cut and machined afterwards to make a nice bracket. We also did it for stress test for the handbrake, just for fun, with very unrealistic results, because this is also handbraking from 100 kilometers an hour back to 0. And then there is quite some excessive force, but even that would be possible. So that even if we would have to do it for some reason or another, we can, and we know we're not gonna crash and burn. Safety factor is a little bit of a different story. So it's strong enough, like it won't fail. But if this was the situation, then we would have, then he would have had to make a few modifications to the setup. So yeah, that's pretty cool. And this is now being manufactured, and it will come in next Thursday. So we'll show you what it looks like back then. And like I mentioned, we removed the entire rear axle. Basically for two reasons. We did notice that when we took out the drive shaft that the bearings were quite old and not in very good condition, so we're gonna replace these anyway. We already replaced the studs with longer ones, which was necessary for us. We also wanted to beef up the drive shaft with an extra precision tubing around the outside. I know it seems a little bit of a weird thing to do, so we're gonna sleeve this with a precision tubing and weld it on this side and weld it on that side, maybe put some rosette welds on the end as well, to make it nice and beef it up a little bit, because this is a lot thinner than the actual drive shaft, the actual shafts, so that's quite funny. But we wanted to make this a little bit stronger. Now getting into the ugly part. Like we know the car is 50 years old and it probably has never had an oil change. So that was really bad and very nasty smelling. Yeah, it was really, really bad. And the bearings, actually these bearings on the side are not so bad. The inside we cleaned it up a little bit, but as you can see and hear, like this bearing is totally crap. And we took out a magnet and put it on the inside, and this all came out of there. So there is some evidence on what it actually is. So that's all gear material that was inside the axle shaft, or inside the axle. And you can see it on the pinion gear as well. So basically all of this is junk. We took it out just to check it, and I had two options: either go and rebuild all of this right now and have it break eventually anyway, because it's probably not strong enough for the power that we have inside the car. So what we're gonna do, actually, it sounds a bit stupid, we're just gonna put it back together, and eventually this will break, and that will be the opportunity, not the problem, to put in something else. Because I actually want to make it coilovers and do all kinds of modifications to the suspension to make that really nice. But for now, we're gonna stick with this because it's probably very easy. And we probably want to put something way beefier underneath the car than this. So we already cleaned it up quite nicely. These bearings are still really good. That bearing's pretty shot. But I've been driving it like this anyway now. Probably put some thick grease in there and we'll see what happens. And we'll let you know when it breaks. And now we have this out. We already planned a little bit ahead of what could be a cool solution for a suspension. So normally there's a big shaft, that shaft over there, that bolts onto here, and it makes sort of a 3-link system with this in the front. It's like that's connected to the car, and these are connected to the car as well as the sway bar. But this is like a nice opportunity to, in the future, make this out of tubular material, actually make it a proper 3-link with the right geometry, and get away from just the regular springs and separate shocks, and make some nice coilover stuff. Make that happen. So we're gonna put this back inside the car, which sounds a bit weird, but that's good enough for now. So now we're actually gonna go and continue where we stopped last week by designing the intake manifold. I already have a design in mind, which I will show you and tell you about. So now we're actually gonna go into Fusion and start designing the intake manifold. It's gonna be a 2-piece, well actually a couple of pieces, but 2 pieces that are gonna be laser cut. One connected to the engine, one will be floating in front of the carburetors, and we'll have some tubing in the middle, which we will have laser cut and shaped by hand a little bit to make work. and I have a neat little idea on how I want to mount them so that it would look pretty cool and have a nice seal to them as well. So yeah, and of course we're gonna make the adjustments that we need to make to the actual carburetor setup as it is in Fusion to match what we really have. So let's get started. So next time we will probably not have this in yet to finally weld up and fabricate, but we will have the stuff in for the big brake conversion kit. So we will do the fabrication on that and probably have one of those fit to the car. In the meantime, we're gonna put this back under the car without any restoration or whatsoever. As I said, we're gonna replace all of this eventually because this is just junk, and I don't really care if it breaks because it's past that point anyway. And then we'll probably put on some bigger kind of beefier axle. Don't know from what, but maybe if you got a good suggestion, just let me know. So that will be it for this time. See you guys next time.